So I want to go over what we're going to discuss in this particular presentation. I'm going to start by giving just a brief overview of SBCA and our role in the component manufacturing industry. Then I'll launch into a quick overview of the loading conditions and truss connections that we covered in part one last week, just in case, one, you weren't able to attend last week, and two, to sort of set up why truss-to-truss connections are equally as important. And as we talk about truss-to-truss connections during this webinar, we'll also talk about how the truss designer communicates information regarding those connections to the building designer and/or the installer. Finally, I will end with a discussion on how defined scopes of work impact review of the truss submittal package, and how today's component manufacturer can be a valuable resource in the building design process. So here we go. For those of you who are not aware, SBCA is the premier trade association for the structural building components industry in North America. We have over 40 years of history, and over that time, SBCA has developed an extensive network that enables us to reach the entire length and breadth of this sort of unique aspect of the construction industry. SBCA has a strong tradition of providing sound engineering and fabrication guidance to its members to help promote their growth and success in the marketplace. That's been our strong spot for many years. But as the market has matured, our primary focus is beginning to shift to helping build connections between companies and individuals throughout the country, more networking and marketing, where whether these individuals are in the same local market or they're spread across the continent. These relationships are primarily built both through face-to-face events, but also virtual events online and through our digital communication network. SBCA's premier face-to-face event is the annual Building Component Manufacturers Conference, or BCMC, which is traditionally held in the fall. We just had it last month. That show brings together thousands of manufacturers and suppliers together for a week of intense networking. They also share ideas, and there's actually an incredible amount of business transaction that occurs there. In addition to that BCMC show, SBCA holds 3 additional face-to-face meetings throughout the year called open quarterly meetings. Those meetings are held across the country and offer anyone a more sort of intimate opportunity to build relationships than BCMC with some of the largest and most forward-thinking CMs in the country. Finally, SBCA has developed an extensive suite of tools and resources for today's manufacturer that range from digital quality management software to an extensive library of online training modules. To give you a sense for SBCA's membership, as you look at this map, you'll see a scatter plot of over 1,300 component manufacturing facilities in the United States. Of the dots that you see on the screen, 907 of them belong to SBCA member companies. As you can see, these facilities reach every community in the country, allowing builders to use these products in any project, no matter where it's located. And that means for building designers who want to design with these, this industry's products, they can find a manufacturer anywhere in the country to use. To give you a sense of scale, SBCA member facilities sold approximately $9.12 billion in product in 2023 out of an estimated total of $9.31 billion. So it is not an insignificant industry by any means. SBCA is an inclusive organization, and we welcome anyone engaged in the light frame construction industry to get tied into our extensive network of structural component manufacturers and their large supply chain. There's an infinite number of opportunities for individuals to get involved, whether you're an architect or an engineer or any kind of building official. It allows you to meet manufacturers, share ideas, solve problems, receive and offer education, and most importantly, build meaningful business relationships that can transform the way anyone approaches their job in this industry positively and also alter the trajectory of their business and their career. Okay, so let's get into what we're addressing today, more truss connections. Now, connections are required to transfer forces between trusses and other structural members. As we discussed in part one, these forces can act vertically, either downward, such as gravity. They can act upward, such as uplift. And they can act lateral, perpendicular to the plane of the truss, and lateral parallel to the plane of the truss. So in several different directions, as you can see in the illustration. Truss-to-truss connections, which we'll cover today, are under the scope of work of the truss designer and the component manufacturer, and are typically shown on the truss design drawings and or the truss placement drawing. All other connections between the truss and another structural member, like a wall or a foundation, are typically the responsibility of the building designer, or they'll follow the prescriptive requirements of the building code. The important thing is that the capacity of those connections needs to be sufficient so that the anticipated vertical and lateral loads can be transferred through the connections without causing a structural failure. Within a discussion of this, established scopes of work when it comes to determining adequate connections is an important thing to adhere to, and I'll touch upon that throughout this presentation. Now, regardless of the connection type used, they must be reviewed and approved by the appropriate party to ensure that they have sufficient capacity to transfer the required loads. And this is because the type and magnitude of the load being resisted will be influenced by several things, including the location of the connection point in the structure, certain framing conditions, and the type of environmental loads that will be placed on the structure over the life of the building itself. So let's quickly go over some of the loading conditions that we covered in part 1 that impact truss and truss design, and also the design of the truss connections. So whether it's a truss anchorage point or a truss-to-truss connection, these different loading conditions help determine proper connections. So vertical forces on the roof system are resisted by the roof trusses. That's then transferred to bearing locations, which are resolved then within the structure itself. Again, following established scopes of work when it comes to determining or reviewing truss anchorage and or truss-to-truss connections is pretty important, because the truss designer is really only responsible for designing individual trusses, independent of the roof system or other structural systems in play. And I'll repeat that. Again, one way to think about it is the truss designer is really designing a 2D element within the 3D structure. They're designing a single element and designing it to resist the loads that have been identified by the building designer. And I keep on using the word building designer, and depending on whether or not you are in a building that's governed by the International Building Code, which does require a registered design professional to be the building designer, and we'll talk a little bit more about that in a bit under scopes of work, or you're under the International Residential Code, where that building designer may or may not be well defined. It may be just the building owner or someone that the building owner has contracted to review construction documents and prepare them. I bring all of that up because, again, the building designer needs to provide adequate information to the truss designer so that they can design each of these elements, but also to review what the truss designer designs within the individual truss design drawings. And we'll talk a little bit more about that process here in a minute. The truss designer will take the information provided in the construction documents. They'll analyze the multiple load combinations provided in the construction documents, and then determine the maximum reactions at the support locations from the loads applied to an individual truss. Now, these maximum reactions are then provided in the individual truss design drawings. And again, the building designer or building owner needs to review them to ensure they don't exceed expected load conditions. So we'll revisit that concept a couple of different times in a couple of different ways. So let's look at two load examples, wind and gravity. Now, depending on the roof shape, the span, configuration, wind loads applied to a roof structure may cause an uplift reaction at the truss-bearing connection locations. Now, this is caused typically by pressure differential created when wind blows over a structure. As you can see in the figure on the left, wind loads applied to a structure result in either upward or downward vertical forces. Again, the magnitude of these uplift reactions will typically be provided on the truss design drawings and need to be reviewed by the building designer or designated person by the building owner. Now, under some circumstances, multi-span truss applications supporting gravity loads can produce uplift reactions at truss-bearing locations under certain load combinations. One good example is what you see on the illustration here is how uplift can result from multi-span framing when you have an interior bearing wall. Commonly, uplift loads are shown as negative reactions on the truss design drawings, and again, should be reviewed by the appropriate party. These two pictures are extreme examples, but in addition to uplift, wind and seismic forces acting on the building to produce lateral loads, those loads are often transferred at bearing locations. The anticipated magnitude and direction of these wind and seismic loads are, again, supposed to be provided by the building designer in the construction documents. When the lateral loads from wind and seismic forces are applied to the structure, they're transferred through the structural members and diaphragms to the lateral force-resisting systems or braced wall lines, and then they're transferred down to the foundation. The connection points between these different building elements, whether they're truss-to-truss or truss anchorage connections, must be sized properly so that you get a sufficient capacity to transfer the anticipated loads. Otherwise, you get some version of, again, what we see on the screen, which are extreme examples. But again, you'll see failures of varying degrees if this is not tended to correctly. Given all this, a complete understanding and analysis of all the code required loads applied is vitally important, and again, a responsibility of the building designer or the building owner. The magnitude and location of lateral loads applied to a structure are dependent on many variables, including the location of braced wall lines, wall heights, anything like that. Again, the truss designer, as I said before, is only responsible for the design of the individual trusses and applying the loads specified in the construction documents. Otherwise, if a piece of information is missing, they have to start submitting a bunch of requests for information. And depending on how well those are replied to, it can really slow down the process or increase the cost of the design. Any lateral loads that are applied to the side of the structure or elsewhere that transfer through individual truss members need to be noted in the construction documents so that the truss designer includes them in their analysis. So how does this impact truss-to-truss connections? So in light frame construction, it's common to design and integrate a girder truss, for example, which is a carrying member to support other trusses or groups of trusses. Truss-to-truss or truss-to-girder truss connections are under the scope of work of the truss designer. Per the ANSI TPI 1 standard, connection information must be included on the truss design drawings for any truss-to-truss connections. For those of you who might not be familiar, the ANSI TPI 1 standard is sort of the governing standard for the component manufacturing industry. The TPI stands for the Truss Plate Institute. The TPI 1 was first issued in 1961 and is updated on a pretty regular basis through a consensus ANSI standard or standard-based revision process. And TPI 1 includes a lot of information that governs both how the metal plates are manufactured and designed, but also how components are manufactured in a facility to how quality control is conducted. And again, that TPI 1 standard requires certain information to be included on the truss design drawings, including truss-to-truss connections. When a truss manufacturer provides hangers or connection devices for truss-to-girder truss connections, typically the hanger types, the fasteners, and their locations are going to have to be effectively communicated to the person who's installing the trusses and the hangers. And typically how they communicate that information is they put the information on the truss placement drawing. Another example of the truss-to-truss connection that we'll take a look at is the jack truss to girder connection. These connections are commonly done using metal hangers or toe-nailed connections. It's important to note that most of today's truss design software has the capability to analyze and identify the hanger or other connection that would be sufficient to transfer the gravity or uplift reaction loads that are calculated from the supported truss to the girder truss. So again, the truss designer is responsible for providing that information, and a lot of times they're going to be using their design software to calculate what those reaction loads are, and then specifying what the particular hanger or connection is needed in order to handle those reaction loads. When the truss manufacturer uses this capability in their software, typically then the required hanger or connection device will be specified on the truss design drawing for either the supported truss or for the girder truss. Examples of some of the manufactured metal hangers used in these applications are shown here on the left. And while ply-to-ply and truss-to-girder connections are listed on individual truss design drawings, it's important to note that many times it can be easy for this critical information to be overlooked or misunderstood by installers. To overcome that, often this connection information is also included, including manufactured metal hanger callouts or anything like that, on the truss placement drawing itself, which is one of those primary documents that installers are usually holding on to see where individual truss elements are placed. We'll talk a little bit more about the truss placement drawing here in a couple of minutes, because there's some important distinctions that even though this important building design information is included on the truss placement drawing, there are sometimes some misunderstandings of what the truss placement drawing is. But again, we'll get into that in just a few minutes. Now, hip roofs are a common design in light frame construction. And these are typically framed accomplished using a girder truss with a series of shorter jack trusses. As the image on the screen illustrates, toe nailing is often used to attach the corner and end jack trusses to the hip girder truss. Typically, toe nailing is sufficient. And that's because these are typically very short spans and have very light end reactions associated with them. Truss applications make toe nailing an efficient and effective attachment method in most cases. When the installer is toe nailing, those connections typically adhere to prescriptive tables provided by the code or other design documentation. Now, multi-ply trusses are trusses designed to be installed, are another kind of truss-to-truss connection that we have to worry about. Multi-ply trusses are trusses designed to be installed as an assembly of two or more individual trusses that are fastened together and then perform as or act as one truss. The plies of a multi-ply truss must be properly connected, obviously, then, to ensure that they perform as the truss designer intends. Fasteners for multi-ply trusses typically are specified for attaching together the individual plies of multi-ply trusses, and that can include nails, bolts, and other approved fasteners. And it all just sort of depends on the amount of load and number of plies involved in the multi-ply truss. Fastener specifications, as well as the location and spacing of those fasteners, will be listed on individual truss design drawings. Again, that will be determined by the truss designer. And that information, again, typically will remain on the individual truss design drawings. That's typically not something that's going to be called out on the truss placement drawing like some of the other things. The truss-to-truss connections between single plies of a multi-ply truss are incredibly important then, mostly to resist the forces that we discussed about earlier that transfer through the roof system. The more plies that are in that multi-ply truss, the more load that system's going to be carrying, and so the more important it is for those connections to be made, to not only be adequate, but to be applied correctly. In cases where the multi-ply truss are not assembled in the manufacturing facility, they may be marked with supplemental tags like the one that you see here on the screen. This just calls attention to the number of plies and the fastening schedule on the truss design drawings to help installers find that information quickly. If the multi-ply trusses are assembled in the manufacturing facility, typically their in-plant QC program and third-party inspection process assures that the fastening is performed per the requirements of the truss design drawing. But if they aren't pre-assembled, those multi-ply trusses are fastened in the field, and those fastened by nails and other screws and that kind of thing must have all the heads visibly visible. They must remain visible so that they can have field inspection. A lot of cases, you'll have some failed inspections because one face of the multi-ply girder will be hidden behind some other framing element, and the field inspection isn't able to verify that all of the fasteners are applied in the proper number and spacing, and that can create some problems in the field. So multi-ply trusses can be up to 4 plies and are permitted to be connected with typically specially designed high-strength screws. Again, screw heads and bolt locations, or screw heads and bolt heads must be visible, and typically they can't interfere with fastening of hardware or other framing members that are intended to be attached to the multi-ply trusses. So looking at this image on the screen, you don't want to be putting bolts in the location of where the connection hangers are going to be placed. Because again, you don't want to cover those heads with the trusses that you put on for inspection purposes. While it's acceptable to locate screws and nails through metal connector plates, typically that doesn't interfere with the performance of the connector plate. Truss designers do need to analyze if there's a desire to locate bolts through connector plates for whatever reason. Again, sometimes spacing and or the location of connection hardware and the connecting trusses may make that kind of analysis necessary. But again, the truss designer will need to conduct that analysis before specifying that kind of location. One last note about multi-ply trusses is a special case of multi-ply parallel core trusses. These can be designed as multi-ply trusses, but they do have special connection requirements due to the 3x and 4x configurations. Typically, the truss designer will specify the necessary connections and list them on the truss design drawings, again, just like all the other multi-plies, along with any special connection requirements. Connection options typically include like metal framing anchors, like those pictured here, as well as structural sheathing, metal gussets, and proprietary high-strength screws. So again, that information will be located on the truss design drawings. So those are the truss connection, truss anchorage, and truss-to-truss connection details. Again, one of the big parts of this and why this education series is necessary and important is that this isn't always done correctly in the field or in the design process. And a big part of that is adhering to established scopes of work. So I'm going to spend the next few minutes sort of talking about scopes of work and defining a few of the terms that I've sort of been throwing around during this presentation. So we're talking about who provides what information and where. So for the building designer, under the IRC, as I said, the building designer is a registered design professional. Again, they're responsible for the design of the building structural system. And unlike the truss designer who's looking at the 2D individual truss element, the building designer has to understand how the vertical and lateral loads are being resolved throughout the entire system. The building designer is responsible for preparing all the construction documents. And within those construction documents, it has to include required spans, loading information for the truss manufacturer and the truss designer to use when they're preparing individual truss designs. So that's really important. I think many of you who are on this call have probably experienced that it's not always the case that you're getting all the information you need from the building designer in order to design individual trusses. And so, when talking to the building design community, this is going to be a very big focus is, what is the scope of work of the building designer as opposed to the truss designer or the truss manufacturer. And I alluded to this before, for structures that require a registered design professional, again, the IRC, the building designer is someone who contracts with the owner for the design of the building structural system and is responsible for preparation of the construction documents. When a registered design professional is not required, typically under the IRC, the building designer is, again, the owner of the building or the entity that's sort of contracted by the building owner to design the building structural system. This is not the truss designer, and it is not the truss manufacturer. So who's the truss manufacturer? The truss manufacturer is the entity responsible for reviewing the contract documents, and they're going to provide design parameters to the truss designer. Design parameters is an interesting one. Design parameters varies widely based on a lot of different factors. Sometimes the design parameters are local code requirements or amendments to the model code that they're incorporating into typically their design software. They may also include limitations such as the raw materials that they decide to use, whether it's species, grade, and sizes of lumber that they decide to stock or can get in their region of the country. It may be the sizes of the metal connector plates that they use or prefer to use and have in stock. Those kind of parameters will typically be input into the design software. Sometimes those design parameters are also impacted by the physical manufacturer, the fabrication equipment that they own, that might either limit the length or the height of the components that they can design and manufacture. What I find is really fascinating, I mentioned in the beginning, I've been working for SBCA for a little over 20 years, and I've spoken to probably 1,000 component manufacturers over that time. And while every component manufacturer in this industry essentially produces the same product, no two component manufacturers really do it the same way. And again, this has a lot to do with local building practices, land and building constraints, capital investments, labor challenges that they face. Also just how the individuals who run those companies or own those companies think is the best way to go about making trusses. And that's an important distinction because for building designers, they really need to build a relationship with a local truss manufacturer. That can be a very powerful and effective relationship, but the building designer needs to understand, what are some of the constraints or what are some of the preferences of that local truss manufacturer? Because if they work with a truss manufacturer, let's say in Chicago, and then they try to work with a different one in Milwaukee and assume that they both operate exactly the same, that's going to create some frustration. And so I bring all of this up because it's good perspective for a truss design or for a building designer who may not have intimate knowledge of our industry, understand that, again, while each manufacturer is making essentially the same product, how they're doing it, how they're going about doing it, what constraints sometimes they place on their design and manufacturing can be a little bit different. One other thing I do want to point out before moving on to the truss designer is that, again, the truss manufacturer is going to be responsible for producing that truss placement diagram. They're also going to be responsible for producing all the individual truss design drawings for review and put those into the truss submittal package. One other aspect of the local component manufacturer is that the building code specifies the truss designer and defines who a truss designer is. But in most cases, And I'll talk a little bit more about the proprietary truss design software that the manufacturer uses. That software is so powerful that in most cases today, unless, again, they are doing a lot of work under the IBC that requires, a truss designer, they may opt to only have truss technicians on their direct payroll. Those truss technicians are different than truss designers, although there's a lot of confusion. And our webinar in this series next week is going to be focused on the differentiation between these different parties and go into greater depth and sort of explore what this means. But in summary, the truss technician is really utilizing the information provided on the construction documents and providing individual truss design drawings that are then reviewed by the truss manufacturer. And in a lot of cases, they may not have to have a code-defined truss designer review and seal those individual truss design drawings. In other cases where maybe they're doing something under the IBC and they do need a truss designer to review and seal the individual truss design drawings by a truss designer. If they don't have one on staff, they usually will contract out, and that can be either to a third-party engineering firm, or it can be to actually the truss software providers that they use. A lot of the software providers, and we'll talk about them by name in just a little bit, do provide this as a service to most component manufacturers when they need it. So the truss designer, again, the truss designer, not the truss technician, but the truss designer is responsible for the design of the individual truss members, preparing the truss design drawings. And again, it's really important for the building designer or the building owner or whoever they've contracted to do a thorough review of each of those truss design drawings to make sure that, again, all of the load conditions are as expected. So the truss manufacturer then puts together the truss submittal package. Again, they'll include the truss placement diagram, or it says truss placement diagram. We've been calling it a drawing as well throughout this presentation. BCSI has a tendency of calling it a drawing versus a diagram, but I think in vernacular we call it the diagram as well. What's important to talk about here with the truss submittal is that there are a lot of jurisdictions in the US, I shouldn't say a lot, but several jurisdictions in the US have really pushed towards requiring truss placement diagrams to be sealed, treating them as engineering documents. And this is a fight that SBCA has been waging on behalf of component manufacturers and alongside component manufacturers for probably 30 years. For the jurisdictions, they're trying to address away or limit their exposure to risk and review by requiring this truss placement diagram to be sealed by an engineer, passing that review process off to, again, a different party. And that's, again, outside of the established scopes of work. But what's really important to point out is that this truss placement diagram isn't an engineered document at all. It's simply a culmination of the individual truss design drawings illustrated out for primarily the installer to know where each one of these individual trusses will be placed in the field for the structure to perform as expected. Again, like as we talked about the truss-to-truss connection information, a lot of times the hangers and the hanger schedule will be listed on this truss placement diagram. Again, not because it's an engineering document, but because it's easier for the installers to find that information, because this is a document they're looking at quite regularly. So when you think about the scopes of work and this whole entire process, this chart, I think, illustrates really well sort of the ideal component design process. The building designer prepares the contract documents, which again specify the design requirements for each of the metal plate connected wood trusses. The contractor then provides the contract documents to the truss manufacturer. The truss manufacturer reviews the contract documents and provides the design criteria and requirements to the truss designer. Again, sometimes there's requests for information that are involved in that process. Again, sometimes they're deciding what limitations they want to place within the design criteria, whether it's limitations on the material that's going to be used, the size of the plates, the size and grade, or the grade and species of the lumber, whatever it is. Then the truss designer does their work, designing the individual trusses and preparing the truss design drawings using the specifications provided through the truss manufacturer. They then return those documents to the engineer drawings and manufacturing specifications to the truss manufacturer, right? They go through that process. And again, the design software plays a very pivotal role in that process. The truss manufacturer then prepares the truss submittal package, which will have the truss design drawing, the truss placement diagram, and then along with the truss connection, hardware details, all that kind of stuff. All of that will be included. And then they'll submit that back to the contractor. And the building designer, the building owner, or the person who's been contracted by the building owner has to review that truss submittal package. And then once the submittal package is approved, then it can move on to the manufacturing stage. So what I want to spend the next few minutes talking about is really why the building design community should care about this. And frankly, it's because while it's likely that the building code won't change significantly when it comes to how trusses are incorporated into buildings and what the requirements are, the capacity and capability of today's truss manufacturer is changing very rapidly. There's been a significant amount of investment into component manufacturing just over the last 3 to 5 years. And it's important for building designers to understand sort of what component manufacturers can do today and why it's important to be knowledgeable about what our industry can do. So again, I said there's been a lot of investment over the last 3 to 5 years. Why has there been that investment? Well, offsite construction didn't become a sexy jargon term overnight. I'll tell you, after attending, the International Builders Show, which the National Association of Home Builders puts on every year for the last 10 or 12 years, it's been very interesting to watch how home builders have decided to recover coming out of the last significant downturn that probably ended around 2012, 12 years ago. In those initial years, the home builders really just wanted to throw bodies at the problem. They want to build more, they're just going to hire more field workers to put these buildings together. And so, at these meetings with home builders at the International Builders Show, they talked about all the strategies that they would adopt to put money into trade programs and recruitment efforts and signing bonuses and just all these things. Again, wanting to bring bodies to bear on the problem. But after like 3 or 4 years of doing that, they realized that they weren't getting any return on that investment. They really weren't seeing any sort of increase in the number of laborers available in the field to help them ramp up production. And it's kind of where we saw a significant increase in builders turning towards offsite and other solutions. And so as builders pivoted, because there weren't enough workers, that certainly got the eye of a lot of investment dollars, a lot of investors outside of the industry, and also got the attention of a lot of players within the production space, mainly large lumber and building material dealers, who have all invested significantly in increasing this sector of offsite construction: roof trusses, wall panels, floor trusses, these structural elements. And what that's led to is really some significant and dramatic increases in everything from automated material handling equipment, improvements in linear saws, which component manufacturers use to efficiently use all of the lumber resources that they bring to bear in a given project, automatic jigging systems, later guided systems, automated nail bridges, even robotics, which are pictured here on the screen. All of these advancements have happened very rapidly, and really what they have allowed the component manufacturing industry to do is respond to this realization by home builders that field labor is not going to help them increase or escalate production. It's going to have to come from offsite. And certainly, if you look at this chart on the right, you'll see that builders still report that carpenters, both finished and rough, and framing crews are some of the hardest labor pools to be able to fill or to replenish. And so again, specifically structural building components are a really good tool to bring to bear there. Again, the driving factor that builders are facing is they don't have enough field labor, and even the field labor that they do find lacks sort of the training and skill that previous generations had. They certainly don't have the experience. And you couple that with sort of this growing environment of liability and enforcement, and it all sort of creates an environment where the builder is looking for any and all opportunities to move production of structural framing offsite. So, one of the reasons why builders have shifted to structural components and stayed there is because it's really allowed them to do some of the things that they've always really wanted to do, which is better control their costs. It's helped them to reduce their construction schedules. It provides a solution that is less disruptive than some of the other things that they're looking at, whether it's 3D printing or modular or CLT. They can really work within their established construction models when using these components. And finally, and probably one of the most important things is that, again, field labor is such a premium for builders these days. And so things like roof trusses, wall panels, and floor trusses produced by the component manufacturing industry are some of the easiest elements for field labor to incorporate today. And so, for building designers, when they're looking at ways to be a hero to their customers, looking at more ways to utilize these structural elements can help them really be successful in the eyes of their clients. Beyond that too, like we've done a lot of framing studies, which we've in the past called Framing the American Dream. We actually just concluded one in Austin, Texas, within the last few months. And what we've found is that, with these structural elements produced by our industry, it really allows someone to finish or complete a framing project using less material, using less bearing locations, so because they can have longer spans. It allows them to source those components many times much easier than some of the engineered wood products that are out there, or certainly any of the other framing options out there, whether it's, again, CLT or modular, easier to erect. Again, all of these things lead to sort of lower overall costs and reduced cycle times. So again, all of these things, I list them all because, this is the feedback that our industry is getting from their customer. building owners. And so it's important to sort of feed that back to the building designers that there's a real opportunity here for them to partner with component manufacturers and specify more of these products to, reap some of these benefits here listed on the screen. I think the last thing I'll say is, when you look at easy to source, availability, that kind of thing, I'll just draw attention back to this map. You look at the over 1,300 component manufacturing locations spread across the United States, it's pretty good distribution. Again, there isn't a project anywhere in the United States that can't be designed and produced with components tomorrow. It's really, one of those things where the building designer can really help in the specification of these products and really get these utilized in projects tomorrow. Now, one thing I think is really interesting is if you memorize this scatter plot and then you apply it to this map, this gets back to sort of, the market share that the component manufacturing industry has. Again, this industry started in 1952 with the invention of the connector plate in Florida. But as you look at sort of roof truss market share, you have states that are between 90 and 100% market share of roof trusses. But there's certainly a lot of dark green states spread across the United States. If you aggregate this out, that market share probably comes to close to 80, 82%. The one thing that affects this significantly is the state of Texas. There's a lot of construction, light frame construction that occurs in the state of Texas every year, but you can see market penetration there is very low. And so that has a tendency of skewing the data more towards, if you aggregate all the construction that occurs across the United States, roof trusses account for about 68 to 70% market share. But when you talk to builders, about their sentiment when it comes to using roof trusses, for example, you have 67% of builders, and these are sentiment surveys done by the National Association of Home Builders and the Home Innovation Research Labs, of a large number of builders. 67%, 2/3 say they're going to use them about the same. So again, pretty strong market share, indication that strong market share is here to stay. But there's an additional 20% that anticipate using trusses more going into the future. So that sort of indicates that over the next few years, we're going to see even more dramatic use or increased use in roof trusses in projects. Another good reason for building designers to think about partnering with component manufacturers, because at least this single product, roof trusses, are going to be in most projects across the US. But again, component manufacturers produce more than just these roof trusses. They make wall panels and floor trusses, and there's significant opportunity for building designers to work with component manufacturers to incorporate these additional framing elements. You look at wood wall market share, for example, there's a lot of market share available. Currently, only 6% of light frame projects, or I should say residential projects completed in the US, use wall panels, whereas 92% are site-built currently, which is a pretty inefficient way about utilizing the limited labor that they have. And you talk to builders, again, ask them that same sentiment question. 60% say wall panel, we don't use wall panels or they won't work for what we're doing. But there's 21% that say they're going to use them the same, and 12% that say that they want to use them more often. Again, a little bit of moderate growth, but a big potential there. If I want to end this presentation, bring it to a close by refocusing on the building designer and their community, and really finishing by talking about the design software that component manufacturers use to design the individual truss design drawings. There has been significant improvement in the manufacturing process, which we covered, but there's also been significant improvement in the proprietary design software. That design software is produced by one of these four companies, MyTech, Alpine, Simpson Strong-Tie, or Eagle Metal Products. And these four companies, they still are, in our industry, identified as the provider of the metal connector plates. But increasingly, one could easily call them software developers as a primary business model. These four companies have made significant investments into integrating other software platforms to increase the power and capabilities of this design software in the hands of the component manufacturer. So, they've incorporated everything from plan reading, building design, 3D modeling, and building information modeling, obviously component design, but also integration of fabrication equipment, and even integration of AI to aid in a lot of the repetitive aspects of plan reading and data entry. And all of these things just make the component manufacturer, when you combine it with their expertise and their knowledge, can really make them a valuable partner to today's building designer. So, in conclusion, again, truss connections are a vital aspect of the building design and its performance. And when we talk about scopes of work, the building designer is really required to provide adequate information to the truss manufacturer so that the truss designer can adequately design each individual truss element. Within that, truss-to-truss connections are going to be specified by the truss designer and placed on the truss design drawings. But each of those individual truss designs need to be reviewed again by the building designer or the building owner, and to make sure that they adhere to what's sort of expected for the building performance. And hopefully what's very clear in this presentation is that the building designer has a lot of responsibility, but again has a very powerful and knowledgeable partner in this process. And the sooner that a building designer can bring a component manufacturer into the design process and utilize their expertise again and their capabilities to sort of figure out what's the most efficient, economical way to get a particular building design accomplished, they're going to be more successful. They're going to save more money. They're going to be more efficient. And so that's what I hope is the main takeaway for the building designer as they think about the component manufacturing industry. So that's the conclusion of this presentation. I want to thank you for attending this webinar. Again, I would love your feedback on how we can improve this presentation for building designer audiences as we take this to groups of building designers in the future. I have found that asking questions in this format, webinar format, can be really difficult, but I've had some great follow-up conversations these last few weeks after each one of these webinars are concluded. So if you want to talk, you want to provide some direct feedback, please shoot me an email. My email address is here on the screen. I'd be happy to give you a call. You'll also get an automated email after this presentation that'll give you a link to an evaluation. I really appreciate the feedback in that survey as well of how well I'm hitting the mark in these presentations. And also, if you wouldn't mind, look for the webinar that we give next week. Next week, again, will be focused on scopes of work and diving more into sort of the defined roles of the building designer, the building owner, the truss designer, the truss technician, the truss manufacturer. Thank you again, and that concludes today's webinar. Have a good day.